Welcome to video lecture on interference in involute gears. So what is interference? Interference is the phenomenon between the two mating teeth when tip of one tooth undercut or damage the root of other mating tooth. Figure shows the two gears in mesh, that is pinion gear with center A is in mesh with the wheel with center B. The line of action will be along MN, which is the common tangent to the base circle of the two gears. The line CD is the path of contact between two mating teeth, in which AC is the addendum radius of the pinion and BD is the addendum radius of the wheel. If the pinion is a driver and rotating clockwise, then the teeth on the pinion and wheels are engaged at D and disengaged at C. Now, if the radius of addendum circle of the pinion is increased, the point C shifts to M. The point C will be coincide with M if the radius of addendum circle of the pinion is made to equal to AM. If the radius AM further increased, the point of contact will be on the inside of the base circle of the wheel. Since an involute can exist only outside of the base circle, therefore any profile of the teeth inside of the base circle will be non-involute type. Hence the tip of the tooth on the pinion will then undercut the tooth on the wheel at the root and remove the part of involute profile of tooth on the wheel. Therefore, the interference occurs in the mating of two gears. This phenomenon, when the tip of the tooth undercuts the root on its mating gear, is known as interference. Similarly, if the radius of the addendum circle of the wheel is made greater than Bn, then the tip of the tooth on the wheel will cause interference with the tooth on the pinion. Hence, interference of the teeth may be avoided if the addendum circles of the wheel and pinion intersects the line of action between M and N. The points M and N are known as interference points. The limiting value of the radius of addendum circle of the pinion is AM, whereas of the wheel is BN. Hence, in that case, the maximum length of path of contact become MN, in which the length PN is the maximum length of path of contact and maximum length of path of approach, and length PM is the maximum length of path of recess. Now, from triangle APN, we have PN equals to AP multiplied by sine of phi. We know AP is small r, so replace this AP by small r into sine of phi. So maximum length of path of approach equals to small r into sine of phi. And from a right angle triangle BPM, PM equals to BP sine of phi. So BP is capital R. So replace this BP by capital R. So the maximum length of path of races equals to capital R into sine of phi. Therefore, the maximum length of path of contact MN is addition of PN plus PM. So substitute for this Pn as small r into sine of phi and substitute for this Pm as capital R into sine of phi. So you can get Mn equals to small r plus capital R into sine of phi. Therefore, the maximum length of arc of contact, as per our previous discussion, maximum length of path of contact divided by cos of phi. Let's substitute the value for this one. So sine of phi divided by cos of phi equals to tan of phi. Next, we'll discuss about the minimum number of teeth required on the pinion in order to avoid interference. So we know M and N are the interference points beyond which the interference will be occurs. Let capital T number of teeth on the wheel, small t number of teeth on the pinion, M module of teeth, small d pitch circle diameter of the pinion equals to small m multiplied by t, small r pitch circle radius of the pinion. So we can get small d by 2 equals to small m multiplied by small t by 2. Similarly, capital D pitch circle radius of the wheel equals to small m multiplied by capital T. Similarly, small capital R equals to pitch circle radius of the wheel, capital D by 2 equals to small m multiplied by capital T by 2. G gear ratio equals to capital T by small t equals to capital R by small r. Phi indicate the pressure angle. Here the point Q is the center of the pinion, whereas the point O is the center of wheel. From triangle MPQ, by using cosine rule, QM square equals to QP square plus PM square minus 2 into QP into PM cos of QPM. Here angle QPM is nothing but this angle with us 90 degree plus phi. So we can get this QM square equals to, replace this QP term by small r, PM term from this triangle OPM. We can write PM equals to capital R into sine of phi. Further, we know cos of 90 plus phi is minus sine of phi, so minus minus becomes plus. In the next step, by taking this r square as common, do the simplification. So in the next step we can get r square into 1 plus capital R by small r into capital R by small r plus 2 into sine square phi. Taking square root from both the sides, we get Qm equals to r into square root of 1 plus capital R by small r into capital R by small r plus 2 into sine square phi. Replace this small r by capital M multiplied by small m multiplied by small t by 2 into this term. Now replace this capital R by small r by capital T by small t. Now from this diagram we know addendum of the pinion is Qm minus Qp. Already simplification for this Qm is done here, just substitute here, and we know the small r is small m multiplied by small t by 2. Just substitute here, take this mt by 2 as common and write the remaining part here. Let ap multiplied by m equals to addendum of the pinion to avoid interference. So where this ap equals to fraction by which the standard addendum of one module for the pinion should be multiplied in order to avoid interference. Therefore addendum of the pinion equals to ap multiplied by m. Equate this term with this term. Here mm get cancelled, so we can get ap equals to capital T by 2, small t by 2 into this term. So we can get small t equals to twice ap divided by square root of 1 plus capital T by small t into capital T by small t plus 2 into sine square phi minus 1. So capital T by small t we know G, gear ratio. So you can get this AP equals to twice AP divided by square root of 1 plus G into G plus 2 into sine square phi minus 1. Next, minimum number of teeth required on the wheel in order to avoid interference. Let us consider this triangle OPN, apply cosine rule. So ON square equals to OP square plus PN square minus 2 into OP into PN cos of OPN. So we can get this step in this way. ON square equals to R square plus small r square into sine square phi minus 2 into capital R multiplied by R into sine of phi multiplied by cos of 90 plus phi. So replace this cos of 90 plus phi by minus sine of phi. So minus minus becomes plus. Take this r square as common from this term and do the simplification. So in the next step we can get ON equals to R into square root of 1 plus small r by capital R into small r by capital R plus 2 into sine square phi. We know that addendum of the wheel is nothing but ON minus OP. We know ON, we know OP. Just substitute here and do the simplification. So you can get the addendum of the wheel like this one by replacing the small r by capital R by this term. So 1 upon G. Let us consider AW multiplied by M equals to addendum of the wheel to avoid interference. So where this AW equals to fraction by which the standard addendum of one module for the wheel should be multiplied in order to avoid interference. So equate this term with this term. Here mm get cancelled. So in the next step we can get AW equals to capital T by 2 into this term. So you can get T equals to 2 into AW divided by square root of 1 plus small r by capital R into small r by capital R plus 2 into sine square phi minus 1. So we know small r by capital R is nothing but the G. Just substitute here. In the next step, by considering this G equals to 1, you can get capital T equals to 2 into AW by square root of 1 plus 1 into 1 plus 2 into sine square phi minus 1. Further we can get this step, that is capital T equals to 2 into AW divided by square root of 1 plus 3 into sine square phi minus 1. If we compare this formula with the previous formula, only